While I'm waiting, there we go. Okay, so these have all been submitted freely by students. So that's maybe the saddest one.
I smiled during mine. You don't even look like you're crying. Other than tear in mine.
All right. Also, send me if you want to send me pictures of different things from yesterday. I thought your costumes were great.
We shouldn't have come in last.
No, but everything people did a really good job.
No, the worst part
but wait, we only
they sounded really concerned for our well-being.
Yeah, Decom was like, I mean, you can come if you need help.
I'm like, first of all, you're not.
Okay, let's move on. It's pretty funny, but let's move on. Okay, so first of all, I want you to find two things. Okay, you ready? So the first thing I want you to find in that is supposed to be a circle in that Charlie Brown's head. Trying to think how Charlie Brown's head would look. So anyway, I just got y'all quiet and I'm drawing Charlie Brown's head. All right, so
That was like a chicken.
let's just start over. All right. All right. So in a circle. Okay. I got it. Okay. So in this circle that we can't see, so I'm getting there. Thank you for. Sorry, everything's so slow. Sorry. Yeah, we'll try it on Alina. So, all right. I can change the color of the circle. Why don't I just do that? This is ridiculous. That's one reason I shouldn't do this. Let's see.
I feel like you would click the circle and go on the top to like the paint.
So anyway,
Try all over again on the next slide.
we're okay. That's what I'm going to try.
Yeah.
So on this circle, all right. So this circle has a radius of 5 inches. And I want you to find, and this is a 30-degree angle. And I want you to find two things. I want you to find this red strip here. And I want you to find this blue area. So I'm going to give you a minute. You can talk to each other how you would do that. So find girls, we're going to be calling this the arc length, is the red strip. And the area of a sector is the blue colored in part.
What did it be done?
I don't remember.
Hey girls, listen. Stop what you're doing. Think about the formula for circumference. Wait a minute. This is really profound. That's why I'm talking real dramatic, okay? Circumference, whatever the radius of the circle is, you just covered 2 pi radians. Doesn't that make sense? Remember how I showed you that? As you went around, y'all remember the radii went around 2 pi times? That's how I define radians for you. All right, so anyway, go. I don't know the answer, so we'll see if y'all get the same answer.
Is that the
I couldn't hear her.
Is that the
Radius is 5 inches. What's a 30-degree angle? That's a 30-degree angle. Sorry, you can't see it anymore. You already have it, huh? I don't care. You give me a decimal or an exact value. I don't care. That's a 30-degree angle. Does anybody have both of them? Hey, girls, you should get these pretty fast. These are geometry questions. They're pretty easy. Let's do it together since we have a short class. It's a little worrisome. Okay, before we go on, 30. Is that degrees or radians?
Oh, I thought you meant that here.
That's right. Oh, that's radians.
This one.
Yeah.
Is that degrees or radians?
Radians.
Why is it radians? Okay, the only reason hopefully that you answered radians or degrees or any is that I implied is it degrees or radians. I'm implying it's an angle. But if I put 30 down, couldn't it be 30 meters or 30 miles? 30 is not reserved just for 30 degrees. The reason I'm saying that is the things I see my students tend to do. That could be pi over 6 inches. Couldn't that be about half an inch? Just because it's got pi in it doesn't mean anymore that you've got an angle. It all depends on the context of the problem. So this line could be 30 inches long. This line could be pi over 6 centimeters long. Do y'all see what I mean? So be sure you're aware of the context that you're in, okay? All right, so moving along, in a normal class I'll let you brainstorm more through this, but everybody should have jumped right to, I would find the whole circumference, 2 pi r, and then what fraction of the circumference is this red of the pink? 30 over 360 would be a good way to do it. I think it's 1/12, isn't it? Is it 1/12? Are y'all okay with what Nicole just said? So 30 over 360. Some of y'all probably are like, okay, that's what I did. Don't fuss at me, okay? So this is 10 pi times 1 over, I mean, at this point you could grab your calculator and type it in. I don't really care. And so I guess if you get it in exact, you get 5 pi over 6. Did anybody get that answer?
Yeah.
All right, the reason I gave this little lecture over here is you did not get the angle 5 pi over 6, okay? You got a length 5 pi over 6. Just a minute, Grace. That red strip is 5 pi over 6. Danielle mentioned decimals. You might give that in decimal. It should be about 5 point something. Oh, sorry. Never mind. Couldn't do that in my head, apparently. Okay, so 2.6. Always give me 3 decimal places. Do you might have 3? 2 point. Well, we have 2 decimal places.
6.1.
Now we have 3 decimal places. All right. 2.618 inches. Now, even as poorly as we all know that I draw, if this is 5 inches, then knowing what we know about radians, this would be about 5 inches. So it looked, because that would be one of my radii going around the circle. So, I mean, I feel good about 2.6 even in my poor drawing. All right, but y'all see that's very logical, just like a fraction of the circle. Grace, let me do the sector and I'll come back to you. The sector, this is what we're doing right now, is like you're finding the pizza crust on your piece of pizza, then you're finding the area of your piece of pizza. So if I go in here and lift this out and go, here's my piece of pizza, okay? This is the arc length, and this is what we call the area of the sector. Do y'all see what I mean? Okay? So, also, some of you have played Trivial Pursuit. It's like an old game that's really kind of fun. And there's this little game piece that as you answer questions correctly, you're putting little sectors in there to ruin your life. Next time you play Trivial Pursuit, you'll think, put in the sector. I wonder what the area of the sector is, okay? So anyway, now let's find the area of the sector. We go back to what I think Nicole said. It's a portion of the whole area of the circle. So pi r squared. And then my radius is 5, so 25 times pi. And then we had 30 out of 360, which was 1/12. So I'm getting 25 pi over 12. And I don't know what that decimal is. Anybody get that in a decimal?
It's like 2.08.
2.
Didn't get the 30. It's 2.083.
0.083 inches squared. Do y'all see where
Oh
the...
wait, I did 2.083 pi, sorry.
Oh, okay.
Do it down in pi, 6 point. Yeah.
But,
Thank you. What is it?
6.545.
Because now we're talking area. We're talking really inches squared. Do y'all see where the square inches come from for the area of the circle? Okay? And so you should think, well, what a great day. Maybe she just did this because this is a short class, because that's like kind of an early geometry exercise that we all need reminding of, I'm sure. But are y'all okay with that? Okay? Let me take Grace's comment question.
It's okay.
Okay. You sure?
Does it matter if we put it as like 25 pi over 12 or like?
Does not matter. I really wanted to press onto decimals today because I want you to really get a sense if you're finding a length or an area, not an angle. You're not finding an angle. Pi is a number, just like 7, okay? So I could have 7 degrees, 7 radians, or 7 miles. There's something else I was going to say about this. Oh, the only reason that you would want to, which is really cool, which is one reason you are using calculators in my class, is because if I go and tell somebody that, say I'm in, maybe I'm making tires, which are round, and I need a circumference of the tire, and there's all different sizes if you look along the road with the buses and the vans and the cars and the fast cars and the, big SUVs, and all of those are there for a reason. And the size of the tire dictates what your speedometer is. If you bought your car with a certain size tire, and then you go and change that tire, like, I'll have to show you something on my awesome Jeep, I had a 2.5 foot slip with big, huge tires on it. But I went and got like all that done to it. So I had to get my speedometer recalibrated because it was set to see how fast those original tires were spinning. If I get bigger tires, the speedometer won't work right because the radius of the tire's different. I'll go over all of that with you today or the next class, okay? The reason I was saying that is if we wanted to then go and make a tire with a certain length, and we were doing all these calculations to make something round, a Ferris wheel, a tire, I'm not saying her in circle things for you in your life, you realize there's lots of real life applications of this. If I tell somebody that's working for us to go make that 5 pi over 6 inches, I don't know how they're going to do that. I don't know how I would do that. Do y'all see I would have to get a decimal? And then the thing that's coming later in the year, that's not even the end of that number. I would get as close as I could and no one would know the difference, okay? Maybe more than 3 decimal places, but then again, you're doing it with a measuring tool, so there's in labs, there's very precise measuring tools that you can get very close. So that's another concept, but we'll talk about that. But y'all see why I wanted to push them to the decimal? Because it's very realistic. It's not I doubt I'm going to look at anybody's comps for building something and it's going to be left in terms of pi. Unless it's given to somebody who's a mathematician instead of something else. Okay. So Grace, we're moving on. Is that okay? Okay. All right. So there's an easier way once you know radians, and I've told you you're already working in radians. You just didn't know it in the past. So let's formulate this. You're always welcome to do what we just did, but you're going to be slower than a lot of people in your class. You'll have to know what I tell you on the quiz just for the little formula, but it's a little formula, okay? If I ask you for the arc length, you're going to get to do this. S equals R theta. The big deal is this cutesy little formula only works if you're in radians. That cutesy little formula, wonderful, succinct, teeny tiny little formula, only works if you're in radians. This will find the arc length. I don't know why anybody calls it S. I'm sure I should look that up, but I don't know. I haven't really cared, okay? S is standing for arc length. I'm not going to say A equals because I'm going to say that for area of a sector. All right, so this is area of a sector. And instead of, I like the thought process of you realizing it was 30 out of 360. It was a fraction of the circle. Hopefully, at least we're all on that track, okay? But if you choose to use these formulas, especially the top one, I use all the time, okay?
That's what I was gonna ask, 'cause I didn't know if that was high school.
Yeah. So did you know that from?
I just like guessed because it's like 2 pi r, so then I'm like, so 30 degrees is pi over 6. So
Could you
pi
try
over-
the math? That's the kind of mind that does really well on this like competition math. That's no pressure. We don't do fluffy things, but you don't get to sleep in. But anyway, that's exactly that reasoning's fantastic. I was going to go there and make a big huge impression, but y'all were going to go wow, but she just did it. Okay, so well, let me show you what Grace is realizing. I'm going to kind of do it backwards from her great thought process. Let's just do it, and then we'll see what Grace is saying. Fantastic. But I'm glad I didn't let you just go ahead and say that because then I wouldn't have my moment. All right. What was the radius of the one I gave you? Was 5 inches. The radius was 30 degrees, which translates in radians. I can't put in 30 here. It translates in radians to pi over 6. So she's been finished for a long time. Did y'all see she went straight to 5 pi over 6? But here's her logic. She realized that the circumference of a circle is in radians 2 pi r. So she just stayed in radians the whole time. Let's find the circumference of a circle using S equals r theta. This is what Grace is saying. I mean, technically, an arc length could even be like this, girls. Because we're going to have tires and DVDs and things that turn around more than once. An arc length, I need to make this. A lot of people think it's just this much a fraction of a circle. But couldn't it be 7.5 rotations of the circle? Like this. So in geometry, and I'm not teaching you y'all geometry, but as a geometry teacher, I probably didn't get past like just that as an arc length. I pick up masking tape. I'll be so uncomfortable.
No, I love masking tape.
Okay, so just imagine that I'm going to in a little while, maybe today or next class, but I'll hand this to somebody to get it started for me again. But if I unrolled it, do you see that would still be an arc length? It doesn't matter if I do this and have a little strip of tape or if I do this. And you don't think about it when you're grabbing a piece of tape, do you? If you need a long piece of tape. You're still ripping off the arc length. Okay, so let's go to the circumference of a circle. What if I wanted, girls, watch this. What if I wanted this arc length? Well, now it's a pumpkin. Okay, so anyway, so that's the radius of a circle, okay? And if you're using this formula in radians, you have the radius times the angle that you've rotated to create that arc length. So here I go, finding an arc length, and I ripped off this much tape. Well, how many degrees is that? 360, but how many radians is that? 2 pi. What's the circumference of a circle? You were already using S equals r theta. So Grace just went ahead and used S equals r theta. So if I can kind of speak to what she was saying, she thought all the way around is 2 pi. She didn't go that far. She went this much of the circle, okay? So in the future, if you want arc length, you can always work in radians. And there's times on tests and quizzes that I actually just go in and give it to you in radians. Then it's good to go. What if I said, find the arc length if the radius is 2 and the angle is 7.8. 7.8 what? What is that right this minute? Radians. All you got to do is go r times theta, done. Now, if you want to construct a circle and think about what fraction 7.8 radians is at 2 pi radians, you are welcome to go ahead. You will get the right answer eventually. Okay? Let me show you how they got the formula. Because I always like to stop in an honors class like this and show you like where this stuff comes from, okay? Because it should make mathematical sense to people with your great minds, okay? We're going to go back to what Nicole did, and most of us, probably myself included, the first time I did it was not as good a critical thinker as Grace was. So I'm sorry, I didn't want to even do that. Oh yeah, that's what we did. Isn't that what? Didn't we take the radius? I'm going to start here. All right, most of you started with the circumference of a circle, and so you thought about the circumference of the circle was 2 pi r. Why am I, hang on. Start over. One more time. All right, so we went to the radius. Now I can't think how I used to do it. What'd y'all do? We went to the angle in degrees out of 360, and then we multiplied that by 2 pi r, okay? Sorry, I was having to think of the old way to do it. All right, so we have our angle out of 360, and we multiplied by 2 pi r. Somebody did this a long time ago. It's not attributed to anybody's name I've ever seen, but 360, would you agree, is 2 times, well, here, let's just do this. What's 2 into 360? 180. Okay. The degrees cancel out just like in your conversions in chemistry where you have inches over inches, those cancel out. And also look at this. What in the world, this is what somebody was like, oh, wow, this is really cool. What if you take an angle in degrees and multiply it by pi over 180? You still have that same angle, but you didn't even know you just converted it into what? This angle in degrees times pi over 180 is the same angle, it's just now in radians. Y'all saw it happen if you had kind of been watching it. You may not have seen it happen, but what you did was you said 30 out of 360 times 2 pi r. 2 goes into 360 180 times. These cancel out. 3 goes into 18 6 times. You all got the answer 5 pi over 6, okay? So do you see, you didn't make, I think what you didn't realize was this little piece. What did the 30 turn into? Pi over 6 times the radius. It's that easy, okay? So, you know, sometimes I know I lose you in the explanation. It looks like I lost me in the explanation this time. But S equals r theta. Just use it, okay? It's very natural for her. It needs to become natural for us. We're just going to go how far along? You know, you've always gone 2 pi times radius. Y'all all see you've been using S equals r theta anyway? Somebody's just always asked you circumference. So you went all the way around with your radius. But if I just want this much, go that many radians times the radius, okay? All right, now area of a sector, you can just go 1/2. Just a second ago we had r squared, and the angle was 30 degrees, but if I use these new formulas, I'm going to have to use radians. And that gives me 25 pi over 12. Does everybody see that? Which is exactly what we got. Y'all okay with that? Okay, now, how did that happen? If most of you said it was 30 out of 360, a fraction of your entire circle. So if I have 30 out of 2 times 180 times pi r squared, what's 30 times pi over 180? It's the same angle, but without you knowing it, you would just converted it into radians, right? Pi over 6. So now we're in radians, you're right. I'm sorry, it's an angle in radians. Here you have r squared, and what's left? Divided by 2. So that's where they got 1/2 r squared theta, okay? That'll get you straight to the area, and you can do it however you want to, but practice on your homeworks using these formulas, okay? So area of a sector is S equals r theta. That's not true. Arc length is S equals r theta. That finds the crust of your piece of pizza. Area of a sector is 1/2 r squared theta. But these equations are only any good if you're in radians. Again, I would argue these equations were only any good. What have you been using since the first time you ever saw formulas for a circle? Nobody told you, but you were already using what? You were already using radians, okay? It's very eye-opening. It's kind of like, kind of like this secret revealed when you see 2 pi r. All right. Okay, so I wanted to pull all that together. Now, tape. Okay, so we're going to go from arc length to linear velocity, okay? Because I'll do this in just a minute. But look at a couple of animations and pictures. See those tire tracks in the snow? And we're talking about how far that car drove. Those are like, especially these, are like straight lines. I mean, let's call these lines. I mean, they decided to turn the steering wheel, okay? But do y'all see these? How did those get there? The tires. And so you can really see what's the effect of the tires were having to roll over like a circle to leave those there, okay? So how would I know how far the car drove? I could measure those lines, but then wouldn't have happened because of this? Okay? Alright, so anyway, this car just went that far. I was going to have a whole lot more, but this car just went this far, didn't it? Where was this? It's the what of this circle? It's the arc length. It's a part of the circumference of the circle, Danielle. Do y'all see what she's saying? Okay, so since this isn't working too well, let's look at this. I had it up, let's see. I don't know where that went. There. All right, now I talked about tires a minute ago. I could also get some tape. And if I had a longer class of tape that was working right now, I could like get somebody to pretend, like get this tape, and then I would get a little piece of Scotch tape, a little, not piece, a little circle of Scotch tape. Anyway, I'd go get some Scotch tape, and I would get like maybe Lily to roll this over 3 times, and we would look at her arc length, her tracks in the snow, and meanwhile I would have rolled over my little Scotch tape 3 times, and we would look at my tracks in the snow, and who went faster? Why would I say she went faster? We rolled over 3 times. We went the same speed. Her arc length was longer. She went further than I did. That in the same amount of time, right? I'm sorry, I forgot to say that. Same amount of time. Where these are going in the same amount of time, aren't they? Okay, so it's interesting. If you're on a carousel with someone, and you get on the outside horse, you are going faster than the person on the inside. Okay. If these are 2 tires and we're side by side on 5th Avenue, you can't get that much speed on 5th Avenue. So let's get on the FDR, okay? So if you're in a car and you're next to an 18-wheeler, okay? If I'm going to go as fast as them, what's going to happen to my tires? Right, like, I could never run as fast as Lauren anyway, but suppose that I was trying, she's taller than me, so what would have to happen to my legs? Unless I wear heels and run in my heels. So I'd have to be moving my legs faster to keep up with her. Or you'd walk next to somebody that's a different size than you, like a little kid. If you walk one to school. If you're walking at a normal rate, you've seen mothers walk through the city with little kids that are just like, and they're just walking. So they're trying to go the same speed, but they don't have the same radius. So there are these things called angular velocity, which are dimensionless. I can go through 3 revolutions, stay with me, which is like 6 pi radians, okay? 3 revolutions, which is like 6 pi radians. And another one could go through the same amount of degrees or radians and not go as far as I did. So I'll write that down for you in a minute, like what I mean by that. But now let's go to this. I had it pulled up. I don't know where it went. Oh, here it is. Oh, no, that's not it. So watch this. Watch this tire roll. Ignore the dramatic music, but watch the tire. Okay, but do you see that the black, I really would almost rather this have been the ground. But what I'm trying to show you is this rolls over. It's leaving a track behind it. It's leaving its arc length behind it. So, to wrap up class today, as this tire rolls along the ground,
Let me tell you about a challenge where
okay. So, as it rolls along the ground, and I put it in motion, it's gonna, as it starts to roll, isn't it gonna leave that arc length on the ground right here as I push that forward? And as I push it more, it's just gonna roll more across here, but whatever touches the arc length is, in fact, it's going along behind it, isn't it? It's like unrolling behind you as you drive away or ride your bike or whatever. And I'll say this real quickly because we need to go. There are even times I brought in one of my son's like little motorized cars and dipped the tires in some water and then just let it go around the room. And what do you see going on behind that? You see a line, but it's coming off of the tires. So right now you're not going to have a whole lot of homework. I'll post it, a memo quiz, and some problems trying these two new formulas or old formulas of your grades. Oh, come back and check with me about your test also.
Any of them right now?
I
Or
don't.
do you do them like
I usually do different things, but